Hey everybody, it's Tuesday, October 25th, and we are on page 45 in the notebook. We are writing down investigation 4.1, observing the motion of a car. Our focus question today is, how do we use Newton's laws to predict motion? We have a lot of vocabulary to write down today, and the vocabulary for lesson 4 is going to be on page 43 in your notebook. The first one is balance forces. Balance forces are forces on an object that are net zero. So you may have 2 or 3, 4, a bunch of different forces on an object, but if they all add up to zero, that object does not move. That is said to be balanced. The second vocabulary word is unbalanced forces. Those are forces on an object that aren't zero. So this is any time that a larger force is pushing and isn't counteracted by the exact same force, that would cause movement, and movement is a result of unbalanced forces. And also inertia. Inertia is the ease at which an object can change motion. So that depends a lot on an object's mass. So the larger a mass, the harder it is to move that object. Inertia. If you think about like offensive linemen for in the NFL, they're really large, and the larger an offensive lineman is, the more difficult it is to move them. More vocabulary on page 43. Newton's first law of motion describes the effect of balanced and unbalanced forces on an object. If it's unbalanced forces, that means there's no change. If there's balanced forces, means no change. Unbalanced forces means a change in speed or direction. This is shown, you should have read the article about Newton's laws. This is shown here, balanced forces. These force arrows are equal. They're both the same. That means this remains at rest. Right here, unbalanced force is a larger force is coming from the left. That's going to cause the ball to move. Same thing, object in motion, all right? An object in motion will stay in motion. Once it's rolling, you can see by those arrows right there. Once it's rolling, as long as the forces are equal, it will continue to roll. Here, once it's rolling, it may increase speed if the arrow is bigger here. It may go up a hill, and that causes the direction to change. Those are unbalanced forces. It's kind of causing acceleration, either slowing down or speeding up. Newton's second law of motion is acceleration of an object is equal to the net force of an object divided by the mass. So this diagram is on textbook page 52. What you have here is a strong force on the same size object is going to cause greater acceleration. That's what those arrows are there. Those show acceleration. A weaker force will show weaker acceleration. So stronger force, more acceleration. Weaker force, weak acceleration. The mass can change also. So if you have the same amount of forces on a large object versus a small object, the small object is going to move faster. The large object is not going to move as much. So it might not be a bad idea to draw these diagrams in your notebook along with these diagrams in your notebook, so you have all of them in your notebook. A little way to make this think is depending on what the forces are happening, force may increase or decrease, and then the mass may increase or decrease. So you might want to write down these showing how an increase in force, if the mass stays the same, is an increase in acceleration. It's kind of putting those words with the two figures we just had. Today in 4.1 in our notebook, that gets on page 45, we're going to be using Newton's first and second laws to predict laws of motion. So today is all about predicting. The lesson focus question and the investigation focus question are here. And yesterday in class, you should have sketched force diagrams for the following situations. You have a stone arch pushing a full-size car versus a bicycle, which one's going to take more force, and then using a full swing of a bat or hitting a ball with a bunt motion. So these are things you should have done yesterday. Just a little review of a force diagram. If the wagon is moving, you might indicate with an arrow. The bigger the force, the bigger the arrow. If friction is a force, it's going to push it back on something also. So today you're going to be discussing with your groups the force in an arch, the force pushing a bicycle or pushing a automobile, and the forces while doing a swing of a bat versus a bunt motion. All right. We may not get to this on Tuesday, but you should sketch a picture of this investigation 4.1. And what you're going to be doing is looking at this and predicting what's going to happen and how you could change this to make it balanced or unbalanced. If you need to see this better, it's on investigation 4.1, the actual investigation video. So after we observe the car, your teacher would have that in front of the classroom. These are the questions that you would write down in your notebook. So our to-do list today is investigation 4.1, observing the motion. Hopefully we get to step 3, discussing and answering your information in your sketch, and then showing, explaining information about Newton's laws at home. If you have any questions, please let your teacher know, and have a good day, Cardinals.